All right, we're gonna get into sequences today. Sequences are like a set of numbers, and you're trying to figure out like a pattern that goes with those set of numbers, or sometimes they'll give you the rule for the pattern, and you would have to come up with the first 5 or 6 terms of that sequence. So if you look, they have an infinite sequence, which is like it goes on forever, so you'd see like a dot, 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 and then a finite sequence ends. So it might just be 8 terms or something like that. So let's see kind of what we've got. Write the first 6 terms of the sequence. So what they've given us here, this a sub n equals 2n plus 3, that is like a rule. It's almost like a function for the terms in the sequence. So a sub n, again, is kind of similar to function notation. So the way, if they gave us this pattern, the way we would write the first term is we would say a sub 1. That means the first term. And you're going to just put in a 1 in the n place. The n represents the term number. So if we're looking for the first term, we would do 2 times 1 plus 3. That's it. Hey, what's 2 times 1? 2. Plus 3, 5. So the first term in this sequence would be 5. That's it. Now we're going to find, we got to find all 6 of them. So if we're finding the second term, a sub 2, we'd say 2 times 2 plus 3. Again, we're substituting these in for n, the term number. 2 times 2 is 4, plus 3 is 7. Looking for the third number, a sub 3 equals 2 times 3 plus 3. 2 times 3 is 6, plus 3 is 9. Now you'll start to notice a pattern back here, 5, 7, 9. You could guess the next 3 numbers are probably 11, 13, and 15, but it's not always that easy, so you should be familiar with just being able to evaluate the term number. 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. All right. The fifth term, 2 times 5 is 10, plus 3 is 13. And the sixth and final term would be 2 times 6 plus 3. 2 times 6 is 12, plus 3 is 15. Great. All right, again, if you look at B, they gave it to us in function notation. F of n equals negative 2 to the n minus 1 power. Remember, we're putting these numbers in for n, the term number. So if we're finding the first term, we could say f of 1 equals negative 2 to the 1 minus 1 power. Now, 1 minus 1 is obviously 0. And don't forget, anything to the 0 power just equals 1. So our first term would be 1. Let's try to find the second term in this pattern. Negative 2 to the 2 minus 1. 2 minus 1 is 1. And negative 2 to the first is just negative 2. Somebody ganked my eraser. Luckily I found it now. All right. Third term. Negative 2 to the 3 minus 1 power. 3 minus 1 is 2. Negative 2 to the second power is positive 4. We got to do that 3 more times. The fourth term is negative 2 to the 4 minus 1. That would be negative 2 to the third, which is negative 8. So if you look at the final answers here, we're going from 1 to negative 2 to positive 4 to negative 8. So as we go down, we're multiplying each one by negative 2. So I bet the next one would probably be 16, and then the one after that would be negative 32, positive 64. We're multiplying by negative 2 as we go down the line here. But they might say something like, find the 100th term, and it would be a pain in the butt to like write out 100 terms. You just go straight to f of 100 to do that. Negative 2 to the 5 minus 1. That's negative 2 to the fourth power, which is positive 16. And then one more. F of 6 equals negative 2 to the 6 minus 1. That's negative 2 to the fifth, which gives you negative 32. That was fun. Oh, wow. That was a real delight, a real treat. I think we have 2 more, in fact. Yes! All right. So it says find the first 6 terms. And here's the nice thing. On this one, they already gave us the first term. That a sub 1 equals -5 means that -5 is the first term. Cool. So if you look here, here's the rule for us. A sub n, that's like a of the term number, equals. Now here's the new part. This a sub n minus 1. That just means your previous term. So the a sub n minus 1 means your term right before that. So if we're figuring out what the second term is in this sequence, we would do our previous term, the first term, -5, and we're just going to subtract 8. So that would give us -13. So now if we're finding the third term, we do the previous term, -13, minus 8. That would give us -21. Yay! Oh, are we looking for the fourth term? Well, we do the previous term, minus 8. -29. Whoops. The fifth term would be the previous term, -29, minus 8, and that's -37. And then the sixth term would be the previous term, -37, minus 8. That's -45. So there would be your 6 terms. You have -5, -13, -21, -29, -37, and -45. Now sometimes they would have you list that as a set. So you could do those fun parentheses. You might be like -5, -13, -21, -29, -37, -45. And it goes on forever, so you could throw the ... in there. But we only needed the first 6 terms. So on this last one, again, they gave us the first term, 2. Let's go ahead and write this one as a set, 2. And then it says we're doing, here's the rule for it. You're doing -3 times the previous term. So for a sub 2, we're doing -3 times the previous term. The previous term was 2. -3 times 2 is -6. For the third term, we're doing -3 times the previous term. The previous term was -6. -3 times -6 is 18. Fourth term, we're doing -3 times the previous term, 18. And -3 times 18 is -54. Look at that, 4 terms in already. Let's get that fifth term. It's -3 times the previous term, -54. That would be 162. Fun! And the sixth, the last term we need to find, -3 times the previous term, 162. -486, I think. I think that's right. And this sequence goes on forever, so we'll put the ... there. Even though they only made us find the first 6, it could go on forever. So there's a couple for you to try here. It says write the first 5 terms of each sequence. So I would recommend pausing here, check back in when you're done, and see if you got the same things. Ugh. So those ones were pretty tricky. But for the first one, I have -4, -10, -28, and -82. Second set, we have 1, 3, 7, 15, 31, and they do go beyond this, but they only asked us to find the first 5. So let's see, I think we're on the back side of the notes here. All right. For each sequence, describe the pattern, write the next term, and write a rule for the nth term. These are where it gets really tough, writing the rule for it. So if you look at number 1, or A, I guess, the numerators are staying the same. I see they're going from negative to positive to negative to positive. That's called an alternating sequence. And there's a rule for that that we can figure out here in a second. So that's fine. But look at the denominators. It's going from 3 to 9 to 27 to 81. So it's taking the term before it and multiplying it by 3. All right. So here's how I want you to think of these. We're going to label them by term number. So this would be like our first term, our second term, our third term, and our fourth term. And we have to write a rule based on the term number. So that if they were like, well, what would it be for the 15th term? You could just substitute in 15 in your equation and you're good. So first thing I see is the alternating sequence. So if it's alternating positive, negative, and it starts with negative, you're just going to do this -1 to the n power. So we're going to say -1 to the n times, and that's it. The positive negative thing is handled by just that. Pretty wild. So then we're going to say, if you look, all the denominators, it's multiplying by 3. So let's maybe think of like 3 to the whatever power. Our first term is 1 over 3. That's 3 to the first power, right? The second term is 1 over 9. 9 is 3 to the second power. So it's always 3 to the n power, 3 to the term number. So if I was looking for the 15th term, I would do -1 to the 15th times 1 over 3 to the 15th. Now, a negative number to an odd exponent would be -1 times, I don't know what this is. But then when I do it times -1, it'd just be -1 over whatever that is. I should probably figure that out. Let's see what 3 to the 15th is. It's probably some ridiculous number. Yep. 143 48907. 14,348,907. Whoo-wee! Luckily, they did not have us find that 15th term. Now it says, like, describe the... I just want you to work on generating the formula from it. Now, if they said the next term would be the 5th term. So we could do -1 to the 5th times 1 over 3 to the 5th. It's a negative number to an odd exponent. That means it's -1. Here, 3 to the 5th, 3 to the 5th is 243. So it'd be -1 times 1 243rd. That's just -1 over 243. Yowza. Brutal. All right, this one's a little friendlier. So if we're looking at our term number, this would be the first, second, third, fourth. It's all positive, so that's cool. So we're trying to come up with a rule that works for this. Here, I should put a sub n over here equals. So if you're looking and it's just based on the term numbers, you might be like, okay, well, it could just be the term number times 2, because 1 times 2 is 2. But is 2 times 2 6? No. 3 times 2 isn't 12, so that doesn't work. So what else do we have? Well, like 2 times 3 is 6, but 3 times 3 isn't 12. Ugh! But check this out. This one is a little ridiculous. 1 times 2 is 2. 2 times 3 is 6. 3 times 4 is 12. So it's always the term number times one number larger. So here's how we're going to write that. Let's say we have our term number here. If I said it was the 6th term, and we were saying, okay, but it's always the term number times the number 1 bigger, what's 1 bigger than 6? 7. So it'd be 6 times 7. We're calling our term number n, so how could I represent one higher than that? You could say that is n plus 1. So this will be our rule. It's always the term number times the next number. So that we represent by n plus 1. So if it's said to find the 19th number, we would do 19 times 19 plus 1. 19 times 20, I know 19 times 2 is 38, so 19 times 20 would be 380. So those kind of sequences are hard to come up with the rule for, because it's kind of like you got to play around like a puzzle in your head and see what works and what doesn't. So there's 4 for you to try here, and then that's the end of the notes. These are pretty tough. Let's kind of just go over these together. So if you look, this is our first term, second term, third term, fourth term. Hey, those line up kind of with the denominator, don't they? Like this 1 isn't a fraction, but if it was, it'd be 1 over 1. So it's always 1 over the term number. 1 over n. So if they said, what's the 50th term? It'd be 1 over 50. Oh, fun. All right, here, first, second, third, fourth. Do you notice a relationship, a pattern with the term number and the number in that sequence? I noticed that it's always the term number times 3. So if we're calling our term number n times 3, we would just write as 3n. Now I see that this one is alternating because it's switching from positive to negative. Here's our first, second, third, fourth. When it's alternating and it starts negative, we use that to handle that. -1 to the n. A sub n equals -1 to the n. Great, that's it. Times, and then we'll figure out the rest. Now we can ignore the alternating part. I see that the number is just the term number. 4, 4, 3, 3, 2, 2, 1, 1. That's it. And then this is a real doozy. This is our first, second, third, fourth. Now as I look down the line here, I notice that it's multiplying by 5. When I notice that, I usually start thinking, okay, so 5 will be the base with the exponent if we're multiplying by 5. But 5 to the first isn't 1. 5 to the second isn't 5. But 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. So it's always 5 to the one number less than the term. So if the term was 5, you would have to subtract 5 from it. Or sorry, subtract 1 from it. So here's how we represent 1 less than that. 5 to the n minus 1 power. Right? Because 5, if we put in 1 minus 1, that would be 0. And 5 to the 0 power is 1. If we were checking the second term, 5 to the 2 minus 1 would be 5 to the first, which is 5. Oh my gosh. If you were doing the 9th term, you would be doing 5 to the 9 minus 1, which is 5 to the 8th, which is who knows what. 5 to the 8th. Whoops. I have a bunch of extra numbers in there. Oh, you know, the old 390,625. So that is obviously the most brutal part of today's lesson, figuring out the equation that works with that sequence. It's tough, but it takes some practice. You could do it. You're wicked smart when you try.